Okay, we're going to go ahead and work out some examples that will help you on this worksheet. These are different numbers than on your worksheet, but the exact same type of problem. Okay, so first off, since you've learned SOHCAHTOA, this can definitely help you to solve other types of problems with triangles when it looks like there's no way of solving it. So for example, I want you to find the area. Okay, this is what you were doing here, finding the area on this of this triangle. Okay, now you should know area of a triangle already is 1/2 the base times the height. Okay, well, we look right here, we don't see a height given to us. Well, that does not mean that you can't draw in a height. So you have to be remembering this when you get to algebra 2 and pre-calc, we're going to do more of this, especially in pre-calc. I can draw an altitude, remember that's another name for height, from the vertex down to the perpendicular of the base. That does not mean it's going to bisect it. Remember, it only bisects it if it's an equilateral triangle or an isosceles triangle. Then it'll be a perpendicular bisector. We do not know that, so we can't say any such thing, but we can draw this in here. We look at the givens. We know this whole angle up here, where theta is 100 degrees. Angle C up there. The length of AC right here is 25. We fill it in. The length of BC is 15. And the length, or when it's capital A, remember that's angle. So that means that's 31 degrees right there. Okay. So remember, we're looking for this height, because that's what we need. And then we also have to find the total length of the base. So we'd have to, if we call that one X and that one Y, okay, we're going to have to find that as well, add those together, okay, and then do half of the base, which is X plus Y, times the height, H. Okay, so the key is now knowing your SOHCAHTOA. So it doesn't matter which one we find first. Well, first off, we want to go ahead and identify our opposite, hypotenuse, and adjacent with our 31 degrees. Okay, now notice I have a triangle here. It's right angle, and that's 31. So we know this angle plus this angle up here are complementary. So that means this has to be 59 degrees up here. Okay. Well, since the whole angle up there is 100, then that makes this 60, 41. Okay, for a total of 100 degrees there. Which then means, remember this is a right angle here, down here, which also then means I can get this angle of 49 degrees. Remember, they have to be complementary. Okay, so now we have these and we can choose which formula we want with our SOHCAHTOA now. So let's say I want to find the X first. And I'm using 31 degrees. I could have used 59 up there as well. It doesn't matter. The key is, since I already labeled this as A, that A is adjacent to the 31 degree angle. If I was to use that 59 up there, I'd have to switch the A and the O, right? The hypotenuse never changes, but then the A would become where the height is, and the O would become where this X is. If I use the 59 degrees, it doesn't matter. You're still going to get the same answer. I'm just going to go ahead and use the 31. So it's adjacent over hypotenuse, which is cosine. So we have the cosine of 31 equals the adjacent X over the hypotenuse 25. Okay, we cross multiply and we get X equals 25 cosine 31. This is the exact answer. Okay, we're just going to go ahead and leave it there because we're going to do exact answers. We try not to round till the very end, and then we'll round to the nearest tenth. Okay, if you want to find y next to the order, doesn't matter because it doesn't matter. If I want to find y now, and I want to use this 49 degrees down here, again, this would be my adjacent, and that would be my hypotenuse, and the O would stay there. Okay, so now I'm using the 49 to solve for y, and it'd be y adjacent over hypotenuse. So it'd be cosine again. Cosine of 49 equals y over 15. Cross multiply, and I get y equals 15 cosine 49. There's its exact answer. So now we have the base, right? X plus Y is the entire base. So these two boxes add together as an entire base. So now we have the base right there, and we have already have the 1/2. Now we need to find the height. Again, it doesn't matter which of these angle measures I use. I'm just solving for the H now. Okay, let's go ahead and change the color so it doesn't look all messy. Okay, if you want to use the 39, 31 over here again, doesn't matter. I can use any one of these angles. Okay, that way I'm not having to erase my A and O as I have it, or I'd use 49, so I'm not having to erase my A and O. I've already got it written down there, and the H never changes. Doesn't matter what angle on that one. Okay, so if I'm going to use 31, then O, or the height here, is the opposite over hypotenuse, which is sine. So I'd have sine of 31 equals H for the height over the hypotenuse, 25. Cross multiply, and I get H equals 25 sine 31. Okay, now I have all I need. I have the height now. I just found the height. The base was x plus y. I found x and y. I'm going to add them together, and I'll multiply that answer by 1/2. So let's go ahead now and write all of that down here. So I have area equals 1/2 or 0.5 if you want. The base, remember, is x plus y. Y is, doesn't matter where I put in, 15 cosine 49 plus x. Where's my x? Up top. Right there. 25 cosine 31. Okay, so 1/2 base, there's the base, times the height. We just found the height right here. 25 sine 31. Okay, so now I can just type that right into my graphing calculator. Okay. 0.5 times all that. Okay, I'm just going to put it all in the calculator at one time. Let's go ahead and bring up the graphing calculator using the test nav one that I've already sent you. It's got a nice graphing calculator right there. Okay, it's right there in the middle. Clear it. Now don't forget mode. It's in radians by default, so I have to come and change it to degrees. Send quit. Okay, let's go ahead and shrink this in here. Shrink. There we go. This end right there. Oops. Where is it? Okay, let's see about shrinking this one in. Okay, I can't go further over than right there. Okay, in order to get my whole graphing calculator on the screen there. Okay, so I'll have to just flip back and forth here to see. Okay, so we have 0.5. Oops. Hold on, where'd that go? Okay, I guess I'm going to have to make this. Where did that just go? Graphing calculator. I guess I'm going to have to use this whole thing here. Come on. All right, 0.5 parentheses. I don't know why I have that there. Okay, 15 cosine 49. 15 cosine 49 parentheses plus 25 cosine 31. 25 cosine 31. Don't forget that parenthesis. Now I have another parenthesis. Open that up. And what's the last one we have here? 25 sine 31. 25 sine 31 parenthesis. Okay. Hit enter. 201.3 is going to be my answer. 201.3 square units because they don't give me units. Area is always square units. It's the nearest tenth. Okay, so there's how you do the problem. You see like that on your worksheet. All right, let's come down here. Notice I'm not going to do all four. I'm just going to do two. I'll do one where I find the Lowercase letters, what do they represent? Side lengths. And uppercase represent angle measures. Okay, we've already done this before. Each one of these is a separate problem. Given information, you don't put them all together. Each one is a separate individual. So if you need to, you draw this triangle out 4 times, okay, because each one's a separate problem. I will just erase the information off it when I go from problem 1 to problem 3. So angle E, remember E's capital letter is an angle, 27. Little d, which is across from big D, is 5. Okay, and it says find little e. Right there's little e, across from big E. So first off, we should already know, since this is the hypotenuse, we can label as hypotenuse, we know it's always the longest side. So E has to be less than 5. We know that these two angles are complementary, so that'd be 63 plus 27 adds 90. Remember, the angle measure goes along with the length of the side, so this little f, if I was finding it, is going to be longer than E. Okay, E is only 27 degrees crossing the 27-degree side. Okay, so just so you have an idea before you even start. Okay, we're solving for E. I can use either 27 degrees or the 63 because I haven't put on the adjacent hypotenuse and adjacent opposite yet. The hypotenuse never changes, so I can put that on right now. Let's say I want to use 63 degrees. Well, then this becomes, let's change the color. If I'm using this 63 degrees, then this is the adjacent, and that's the opposite. And of course, then we already know the hypotenuse never changes. Okay, so then I'm solving for E, I'm not solving for F, so I need adjacent over hypotenuse, which is cosine. Cosine of 63 equals the adjacent, little e, over the hypotenuse, 5. Cross multiply, I get E equals 5 cosine 63. That's the exact answer, but notice it doesn't want the exact answer, it wants the nearest tenth. So E is approximately equal to, now just plug that in the calculator, 5 cosine 63. 5 cosine, 63. Enter. 2.3, right around to the nearest tenth. 2.3. Okay, that makes sense because it's less than 5, a decent amount less than 5. So this is 27 degrees. Remember, this is 90 degrees. 90 degrees is a lot bigger than 27 degrees. Okay, so there's how you do that one. Okay, now I'm going to erase all that. So if you haven't written it down, pause it, put that on there, and then I'm going to go to number 3. Again, you can just draw that same triangle over again off to the side. You know, I could have labeled that as 1 and draw the triangle again, put 2 next to it, you know, all that kind of stuff. So this is now number 3. Little f, which is across from big F, is 7. Little d is 17. And they want me to find angle F. So that's my theta. Well, remember, the hypotenuse never changes. So go ahead and do that first. And since we're going to use this angle, we're solving for this angle. This is the opposite, and that's the adjacent. So we need opposite over hypotenuse, which is sine. So sine of theta equals opposite over hypotenuse. And how do I get rid of sine? Because I'm solving for theta, inverse sine. And now I just type that in my calculator. Inverse sine of 7/17. Inverse sine of 7 divided by 17. And that's 24.3. Okay, so what's the nearest tenth? So theta is approximately, what did I say, 27.3? 24.3. 24.3 degrees. Okay, so there's that one. All right, let's go ahead and move down here now. Find the missing side lengths exactly. Keyword exactly means leave radicals in your answer if there is one. Don't worry about this number outside the radical first, inside second. That's for clickers. We no longer have clickers, so I can't do that. You're just going to do it by hand on your paper there. And simplify all radicals in the final answer. Okay? So, this tells you this is a 45, 45, 90 for 1 and 2. 3 and 4 right here, we have 30, 69 degree triangle. So I should write down my relationship right next to it. A, and A root 2. Okay? So if I'm given the legs, notice it says legs plural because they're both the same. So isosceles right triangle. 4 root 24. I could choose to go ahead and simplify the root 24 first before multiplying by root 2 to get the hypotenuse. So if I did that, root 24, don't forget that's 2 root 6. So I'd have 4 times 2 root 6, which gives me 8 root 6. That's a leg. Let's put leg there. So once the hypotenuse, you multiply by root 2, right? It's a root 2. So I'm going to multiply by root 2 now. And that gives me 8 root 12. Of course, then I have to simplify that. Root 12 breaks down to root 4 times root 3. And root 4 is 2. You should know that. So 8 times 2 is 16 root 3. There's my answer for the hypotenuse in simplified radical form. Okay, and then we're going to go backwards. We're starting with the hypotenuse, going back to legs. So we divide by root 2. Well, I can divide my radicals right there. 10 divided by 2 goes right away, and that gives me 4 root 5. 10 divided by 2 is 5. You should know from algebra 1, root 10 divided by root 2 is the same thing as writing one big radical with 10 divided by 2 inside of it. Of course, 10 divided by 2 is 5, so you get root 5. Okay, those are the same thing. If you do not know that, you need to know that for algebra 2, pre-calc. Okay, that does mean the same thing. All right, so there's our both directions for 45, 45, 90. Now we're going to do with 30, 60, 90. Obviously, 6 root 1 is just 6, so it's just gone. How do I get to the 60-degree side? Add on the root 3, which really means multiply by root 3. And how do I get to the 90-degree side? Double it. 6 times 2 is 12. Okay, here I'm starting at the 60-degree side. If you're writing down your relationships, it'd be a root 3, and 2a. So since I'm given the 60-degree side, that's a root 3. So I need to divide by root 3 to get down to a. Okay, so a therefore is 6 root 3. Because 9 divided by 3 is 3. 6 root 3. And how do we get from the 30-degree side to the hypotenuse? Double it. So 12 root 3. Okay, there's that. And find the missing piece. We'll just do, you know, we already did both of these up top. I did one where we found the length of a side and one where we found the angle measure. So I don't need to do that again. All right, here's another one similar but easier than the top one. A little less work in the top one, but the same idea. Okay, there's a formula for this, but I'm not going to teach you to work on memorizing the formula. I want you to use your brain like you did in number 1 and just drawing your own right angle. Again, we don't assume it's isosceles. Okay, they give me the theta is 33 degrees, so I put 33 right there. They give me A is 4, and B, the entire length, is 9. Notice where I put the 9, I put it right in the middle underneath that altitude. That means that represents the entire length. If I'd put the 9 over here, oops, I guess it's going to take the whole thing. If I'd put the 9 over on this side, that means it's 9 from here to here. That's not what it says. If I put the 9 over on this side, it means 9 is from there to there. That's not what it means either. So if I want it to mean the entire length, I put it right underneath the middle section itself. So I put a 9 right there. That automatically means the entire length. You need to know that. They expect you to know that if you see that in a problem. Okay, so I need the height, right? Because we know what's the area of a triangle. 1/2 the base times the height. Well, don't I already have the base? They've already told me the base, 9. 1/2 of 9. So I need to solve for the h and then just plug it in. I'm only missing one piece here. That's nice and easy. Okay, so again, let me change the color. This would be my adjacent side. Obviously, this would be the opposite, and the hypotenuse is always across from the right angle. So since I'm looking for the height, that's opposite over a hypotenuse, which is sine. So the sine of 33 equals the opposite, h, over the hypotenuse, 4. Cross multiply, I get h equals 4 sine 33. So there is my height right there. 4 sine 33. And now I just type this in the calculator. That'd be the exact answer, but we want the nearest tenth. So now you type in the calculator. 1/2 of 9, you could, if you know that, that's 4.5. You can just type in 4.5 times 4 sine 33. Or you can just type it in, all it is right there. So I did that 0.5 times 9 times parentheses. What was it? 4. Oops, right there again. 4 sine 33. 4 sine 33. Okay, and my answer is 9.8 to the nearest tenth. So 9.8, and there's no units, so units squared. Area is always squared. Okay, not u squared. Okay, so it's a little similar to number 1, except for much easier because you're already given the entire base itself. All I'm having to do is find the height and plug that in. 1/2 base, they're giving you that. All you do is solve for the h for the altitude that I drew in there myself. Okay, and use SOHCAHTOA to solve for the h, plug it in the calculator, and there you go. All right, that ends it.